Welcome to Freedom with the DSA. Let's make an algorithm walkthrough for the second largest element, the name of the approach, the do-pass approach, and this is the respect to time and space complexity. This is the given unsorted input array and the largest element is 35 and the second largest element is 34. We need to return 34 as the expected output. So this is our make it work approach. What does it mean? We sorted the array and we successfully found the second largest element. But now let's ask an important question. Do we really need to sort the entire array just to find the second largest element what we did in the naive approach? We build a basic intuition because the sorting takes the worst case time complexity before of n log n time. As the size of the input array increases, the computational time to get the second largest element is also increases. So, but our actual requirement is very simple. The requirement is we only need the largest and second largest elements. That's it. So we need to make a smart transition, a better transition. So now let's move from make it work to make it better. What is make it work? Here is a naive approach what we built in the previous session. That is, we've built a workable solution, but it is worst case time complexity before and again we need to reduce the time complexity and we need to improve the efficiency of the algorithm by making some modifications and changes. So we need to make it better. So in this better approach, so instead of sorting the entire array, we can use a two pass approach. So the two pass approach is nothing but we are traversing the array twice. So in the first traversing, we find the largest element. In the second traversing, we find the second largest element. How to find the largest element followed by the second largest element? What is the algorithm? So what is the procedure and what is the reason for this time and space complexity? Let's explore. Let's make an algorithm walkthrough. So in step 1, initialization before either loop begins. So here we initialize a set of variables that is n, largest and second largest. Let me explain. N is the size of the input array containing 6 elements 12, 35, 1, 10, 34 and 1. Here we initialize two variables largest and second largest with -1. You can get a doubt why we initialized with -1 because the values within the slots from the index 0 to 5 from the first index to the last index, all the values are positive values. To replace these positive values easily, for the easy replacement, for easy updation of largest and second largest, so we just initialized with the -1. That's it. That is the reason. So here is the entire initialization is done. So as you can observe, we have four different phases: initialize, loop 1 to find the largest, loop 2 to find the second largest, and in the fourth phase we return the corresponding second largest element as the final result. So this is the flow chart where we are. So this is the pseudocode flow chart. So this is the initialization is done. The largest and second largest is initialized to -1. Here is the traversing gets started at the index I is equals to 0. Here in the loop 1, we traverse from the index I is equals to 0 till the last index I is equal to 5. So we will check the condition. By default, we check the condition in the first traversing, the current ARR of I value with the largest. As you can observe, in the initialization phase, the largest is initialized to -1 and it is updated to 12. What is the reason? Because we are checking a condition. Here ARR of I value, the current value compared with the largest, 12 greater than -1. This -1, the largest is -1 in the previous initialization phase. So as we check the condition, the current ARR of I value at ARR of 0 is equals to 12. 12 greater than -1, the condition is true. So here the largest is -1 is updated to 12. So as you can observe, at index I is equals to 0, the value is 12. Since 12 greater than -1, the condition is true, so the largest is updated to 12. So hope you understand the story here. So this story keeps on repeating till the last index I is equals to 5 for the loop 1 to find the largest. Simple. So this is the story at the index I is equals to 0. Now let's move forward. As I moves forward, at the index I is equals to 1, again the largest is updated to 35. If you observe, at the index I is equals to 0, the largest is 12. Now it is updated to 35. Same, again the story is same. At the index I is equals to 1, 35 is greater than 12. Again the condition is true. Largest is updated to 35. Again I moves forward, but largest not updated here because 1 is not greater than 35. The current ARR of I value, ARR of 2 is equals to 1. So 1 is not greater than 35, condition is false. Again the largest stays 35. As I moves forward, ARR of 3 value is 10 and 10 is not greater than 35. Again the condition is false. The largest stays at 35. Again I moves forward. So ARR of 4 value is 34. So at the index I is equals to 4. 34 is not greater than 35. Condition is false. So the largest stays at 35. Again I moves forward. At ARR of 5 is equals to 1. 1 is not greater than 35. Condition is false. And largest stays at 35. So this is the entire traversing. First traversing is finished and we successfully find the largest is 35. So what happened in this step? Loop 1 has scanned every element exactly once. We scanned each and every element exactly once and we finally concluded that largest is 35. So now we will lock this largest element 35 and we take this as a reference to find the second largest element 34. So here we successfully finished the loop 1, find the largest. Now it's turned to creep. So successfully finished the loop 1. We successfully finished loop 1 finding largest. Now it's time to traverse again. The second traversing starts from the index I is equals to 0 till the last index I equal to 5. Here we are checking two conditions. Simple. Here we need to compare the current ARR of I value with the second largest. Simple. In the loop 2, again traversing, we will make it traversing. So here the current ARR of I value is compared with the second largest and the current ARR of I value is not equal to the largest. So if you observe in the previous phase, the second largest is still initialized set as -1 only. We didn't touch the second largest element. Now we will make a comparison and check. We need to find the second maximum in the entire array. So here we are checking two conditions. So in order to update the second largest, so what is the criteria, what is the condition is nothing but the current ARR of I must be greater than the second largest and current ARR of I value should not be equal to the largest. Then only we can find the second max. So as we move forward, you will get more better clarity. So here second largest is -1. The current ARR of 0 value 12 is compared with -1. As you can observe, second largest is -1. So 12 greater than -1, condition is true and 12 is not equal to 35. Yes, condition is true. So now the combined condition is true. Second largest is updated to 12. As in the previous, second largest is -1 is updated to 12. Hope you understand. Now this is the entire story keeps on repeating till the last index I is equals to 5. So as I moves forward, here 35. 35 is not equal to 35. Here is the second condition becomes false at the index I is equals to 1. So 35 is the largest, so it's excluded. So the combined condition is turned to false. So no change. The second largest remains as it is. As I moves forward, at the ARR of 2 equal to 1, again the current ARR of I value 1 is not greater than 12. The first condition itself is false. The both conditions must be true in order to update the second largest. If one of the condition false also, we will not update the second largest. So here the combined condition is false. Again, no change. As I moves forward, 10 is not greater than 12. ARR of 3 value is 10 and 10 is not greater than 12. Combined condition is false, no change. Again, I moves forward. Here is the condition is true. 34 is greater than 12. Why? Because in the previous iteration, I at the index I equal to 3, the second largest is 12. Now 34 is greater than 12. 34 is greater than 12 and 34 is not equal to 35. Condition is true. Again, the combined condition is true. The second largest is updated to 34. Again, as I moves forward, the index I is equals to 5. 1 is not greater than 34. The first condition itself is false. So at ARR of 5 equal to 1. So the combined condition is false. Again, no change. So here is the final result. Loop 2 has also scanned every element once. Second largest is now 34, the biggest value in the array that is in the overall largest. Yes, 34 is not the final largest. 35 is the largest. We take this 35 as the reference to find the second largest, which is 34, by making dual traversal. Two times we traverse the array to find the largest, followed by the second largest element. So this is the loop 2 to find the second largest. So now the loop is also finished. As you can observe, this turned to green. So this is the return result. So the function returns second largest 34. So this matches expected output for the given input array ARR. So hope you understand the algorithmic intuition for the two-pass approach. So we are traversing the array 2 times in order to find the second largest. So here you can observe how it is efficient, because as you can observe in the naive approach, the time complexity is big O of n log n. So in this two-pass approach, the time complexity is big O of n only. So this is the linear time complexity. So this is now it's time to analyze the time and space complexity for the second largest element. So as you can observe, the array is scanned twice, one to find the largest and another one to find the second largest. So we didn't take any extra space, so no extra data structure is used, so that the space complexity is constant, which is big O of 1. So this is the entire algorithmic core logic building intuition, followed by the time and space complexity analysis. If you observe, here is a hidden point that you need to keep in mind. Here we are traversing the array twice. So big O of 2n, actually the time complexity is big O of 2n, as we ignore the constants. So 2 is ignored. So that is the reason we written as big O of n. So this is the entire story of two-pass approach in order to find the second largest element for the given unsorted input array. Hope you understand. Let me demonstrate the code execution using Java programming language. So the name of the problem is second largest and the approach is two-pass and the time complexity is big O of 2n, because we are traversing the array 2 times in order to find the largest element followed by the second largest element. So we ignore the constants. So the 2n can be written as n. Big O of n is a linear time complexity and we didn't use any extra data structure. So the space complexity is big O of 1, and this is the unsorted input array which we used in order to build the core logic building intuition, and the expected output is 34. So you already know it. So let me demonstrate the code execution without any delay. Let's get started. So let's start with the import statement. Import space java dot util dot star, and class space name of the class is main, because here we declared as main.java. So class space name of the class is main. So here public, static, these are the reserved keywords, and the output data type is int. And that let's give the name of the function as second largest, and the array data type is int. The array data type is int, and name of the array let's give as ARR. So let's declare, the step 1 is to declare the size of the array. Int n is equal to ARR dot length. So this is the size of the array. Okay. Now let's declare two variables, int space let's give as largest equal to -1, and int second largest equal to -1. So here we use largest variable is used in first traversing, first traverser, second largest is used in second traversing, second traverser. So we will run a loop, for loop int I is equals to 0, I less than n, I plus plus. Here this is the first traversal from index I is equals to 0 to I is equals to n minus 1 till the last index I equals to n minus 1. Here in this first traversing, we will check the condition, the current ARR of I value with the largest. If ARR of I value, the current value is greater than the largest, then we will update the largest as ARR of I. So when the condition is true, here we will check the condition. Here we will check the condition. If the condition is true, then we will update largest. So if the condition is false, if the condition is false, we will come out of the first traversing. If we come out of the loop, once the traversing is finished, once we finish the first traversing, then we'll make a second traversing. Again we will run a loop, for loop int I is equals to 0, I less than n, I plus plus. So let me replicate this same comment once again at here. Here this is a second traversal from the index I is equals to 0 till the last index I equals to n minus 1. Again we will check the condition, but here we will check the condition, the current ARR of I value we will compare with the second largest. We will compare with the second largest, and we will make a comparison and we'll check the one more condition, the current ARR of I value must be not equal to the largest. If these two conditions are satisfied, then only we will update the second largest, which is equal to ARR of I. Here again check the condition, and if the condition is true, then only we update second largest. Okay, so once we finish the second traversing, we will come out from the second traversing and we finally return second largest. So this is the entire core logic building intuition for the two-pass approach. And let me create the main method, which is public static void main string args. So let me create a three predefined test cases. Let's create three test cases. So array data type is int, name of the array as arr1. So within the curly braces, let's replicate the values which is there in the comments section, which is 12, 35, 1, 10, 34, and 1 here as it is. So this test case, if you already know, we use this test case in our logic building intuition example. So system dot out dot println, and the name of the function, we need to pass this function second largest, and we need to give the array arr1. Sorry, I forgot here equal to. Okay. So let's replicate these two test cases again and again for two more test cases. So if you recollect, rethink, recall about the naive approach. Just a second. Okay. If you recollect, rethink, recall about the naive approach, we discussed two scenarios. In scenario one, what if the largest element duplicated twice? So here is a back traversal concept will come into the picture. If you remember, in the scenario one, we discussed what if the largest element duplicated twice in the naive approach. So let's give test cases as 35, 5, 35. And this is scenario number one. So this is scenario number one, duplication of elements twice. This is scenario number two. Scenario number two. So what if the largest element duplicated at all the indexes? In the worst case scenario, what if the largest element duplicated at all the indexes? That is 35, 35, 35. So let's change the name of the array as 2, arr2 in the second test case. And let's change the name of the array arr3 in the third test case. For better clarity, I will mention here, what if largest element duplicated twice? We discussed sorry, we can keep it very simple. In the naive approach we discussed. So in the scenario number 2, what if the largest duplicated at all indexes? So this is the entire code demonstration. I didn't mention the second test case and third test case. That is the reason I want you to recollect, rethink, and recall about the previous approach, the naive approach, the two scenarios. That is the reason I didn't mention in the comment section. So I replicated these two test cases on my own. So ARR2 and ARR3. So this is the entire code demonstration. So let me run this code. See, as you can observe here, in the first test case, 34 is the second largest element, and in the second test case, 5 is the second largest element, whereas in ARR3, third test case, there is no second largest element. We simply return -1 as the output. So hope you understand the entire code demonstration. So here is the first traversing followed by the second traversing. So we will find the largest element followed by the second largest element, and this is the linear time complexity. And here we need to make a change. we need to improve the efficiency of the traversing of the two-pass approach. Can we find the second largest element in just single traversing with a single scan? Is that possible? Yes, it is possible. So that approach we will see in the optimal approach, which is the final optimized solution. So we will discuss in the further class. So hope you understand the entire flowchart and algorithmic intuition how this approach looks like. So keep practicing, keep improving. If this explanation helped clarifying the concept, consider liking the video and let me know in the comments. If you have questions or want me to cover a related topic, subscribe to stay updated with the rest of the series. See you in the next video. Thank you. Have a nice day.